Okay, so our task in lesson 2 is to identify all the unique characteristics of a quadratic that's written in standard form. Now remember, first of all, that standard form means y equals ax squared plus bx plus c. All right? And we want to identify, before we do anything, what a is, what b is, and what c is. Now, we have to find these 6 different things. Number 5 I broke into 2 different categories. The first thing we have to do is decide, is it a max or a min? If a is greater than 0, think smile, which gives us a curve that appears or gives us a minimum. If a is less than 0 or negative, think frown, which tells us we're dealing with a maximum. The second thing that we have to discover is the y-intercept. The y-intercept is simply 0c. It's 0 and the constant value of the quadratic. The next thing we have to find is the axis of symmetry. The axis of symmetry, we need to use a formula. And the formula is x is equal to the opposite of b over 2 times a. The opposite of b over 2 times a. I wrote it like that for you, okay? And then we have to simplify that fraction, all right? After we find the axis of symmetry, we now know a value of the vertex. We're going to write it as x comma y, and the x came from the axis of symmetry value. To find y, you substitute x into the original equation and simplify to find y. The last thing that we got to find is the domain. Well, domain for parabolas is very easy. It's always all real numbers. And then we also need to find the range. Now the range depends on the a value, and think about the smile or the frown. If a was greater than 0, I'm smiling, therefore y's have to be greater than or equal to that y value at the vertex. If a is less than 0, then y is less than or equal to, for the range, the y value at the vertex. So let's try to do a couple of these, see if it makes sense. All right? First thing we got to do is identify a is 7, b is negative 28, and c is 14. All right? I look at a is positive. Positive things make me smile. Because I am smiling, I know I am dealing with a minimum. I know the y-intercept will be the point 0c, or in this case 0,14. I know the axis of symmetry, I have to do some work. That's x is equal to the opposite of b over 2 times a. And then I simplify that to x is equal to 2. That 2 becomes the x value at my vertex. But now I need to find y. I go back to the original equation, and I say 7 times 2 squared minus 28 times 2 plus 14. And I need to clean this up to get an exact value. So remember your order of operations here. 2 squared is 4. 4 times 7 is 28. Minus 28 times 2 would be minus 56 plus 14. Now, it's okay to use a calculator here as well. 28 minus 56, that's at negative 28, plus 14 would be negative 14. This y becomes the y value at the vertex. Domain, always, all real. The range, I got to think about the a value and the y value of the vertex. Because it's a smile, I know its y's are greater than or equal to. And because the y value of the vertex is negative 14, then the range would be y is greater than or equal to negative 14. Let's do another one where we have an a value that is negative. So if the a value is negative, let's write down our a, b, and c first. If a is negative, I'm unhappy or frowning. That tells me I'm dealing with a maximum. I know the y-intercept is 0c, or 0, negative 18. I know the axis of symmetry is an equation. X equals the opposite of b over 2 times a. That would give me negative 6 over negative 6, or x is equal to 1. That 1 becomes the x value of the vertex. But now I have to go find y. I go to y, and I substitute in 1 wherever I have an x. I follow the order of operations, so I have 1 squared is 1, times 3 is negative 3, 6 times 1 is plus 6, minus 18, or y is equal to negative 15. That becomes the y value of my vertex. The domain is all real. And the range, because it's a frown, be y is less than or equal to the y value at the vertex, negative 15. Hopes this helps.